Our next set of examples for reciprocal trigonometric identities is to do what we've done before. Figure out angles. Let's if I know a ratio, let's figure out an angle in a right triangle, like we would have done in grade 10. It says each angle is in the first quadrant, so we're only looking at right triangles and angles less than 90 degrees. It's to determine the measure of each angle to the nearest degree. So we've got this first one. We've got the cosecant of A is 8. If this might have been like the sine of angle A is 8 or 1 over 8 or some decimal, we would have gone to our calculator. Let's grab it. Here it is. There it went. Let's get it back. There it is. Okay, so the sine, we would have done sine inverse to get the angle if we know the ratio. Well, look at your buttons on your calculator. You got sine, cosine, tan, but then you've got like sine inverse, cos inverse, and tan inverse, which are not the same as cosecant, secant, and cotangent. So here's how we're going to handle this. We have to be able to evaluate these on our calculator, but we don't really have a button to do it. So here it is. If cosecant of A is 8, and remember this is 8 over 1, let's write it as a ratio, 8 over 1, then remember the cosecant was the reciprocal of sine. So if cosecant of A is 8 over 1, then what's sine of A? Well, remember that cosecant of A would normally be the hypotenuse over the opposite. So if cosecant of A is 8 over 1, and that's the hypotenuse divided by the opposite, then sine of A must be the opposite divided by the hypotenuse. So that sine of A of this ratio must be 1 over 8. And now I've rewritten it in terms of sine, and I can use my calculator to do this part. Angle A must be equal to sine inverse of 1 over 8. So we can break the calculator out now and figure out what angle A is going to be. So clear this out. So I could go second function sine of 1 divided by 8. Now notice my calculator can do that. It's all in 1. I close that bracket up. So I can put that all in there and I hit equals. And I get 7.18. So angle A is about 7 degrees. Okay, now if I do B, this is sec of B. Sec, or secant of B, the sec is the reciprocal of cosine. So sec, if you look it up from our original slides, is going to be the hypotenuse divided by the adjacent. So if sec of B is 5 over 2, what's cosine of B? Well, that's got to be the adjacent over the hypotenuse, so that's got to be 2 over 5. So now I can use my calculator to finish that off. Angle B is the cos inverse of 2/5. And you can look that up on your calculator. I'll let you do that part. That would just get you the angle. Let's do this one over here. If cotangent of C is 5/16, we need to figure out C. So what's the tangent of C? Did you say 16 over 5? You got it. And then you can go tan inverse to get angle C. So you go tan inverse of 16 over 5, punch that in your calculator, and you've got angle C. We got one more kind of set of questions to do here, which is another type of question that we've been asking before. Now if I extend my angles past 90 degrees, I look at the full circle here. We've got 0 to 360 degrees. I got to figure out two angles between that 0 and 360 that have a cosecant of -2. So let me just write this out. So what it says here, the cosecant, so cosecant looks like this. Cosecant of some angle equals -2. I need to figure out which two angles would give me this value here. Well, as we saw in the last slide, it's hard to think about this cosecant. Let's rewrite it in terms of the reciprocal of cosecant, which is sine. So sine of the angle must be the reciprocal of this one, so that's going to be -1/2. Alright, so this is my problem here. What two angles for theta will give me sine of that angle to give me negative a half. Alright, here's how we do this. We've got our axes, and we've got our rule, our cast rule. So cast rule. We've got cosines are all positive down here. They're all positive in this quadrant. Sine is only positive in this quadrant, and tangent is only positive in this quadrant. Notice the angle here is giving off a sine ratio as negative. So that means it can't be in the quadrant 2, because that means sine would be positive there. And it can't be in quadrant 1, because that means they're all those ratios, sine, cosine, tan, are positive in that quadrant. So it's got to be in the third quadrant. So our terminal arm is lying here, and it's also got to be, if it's going to be here, it's going to be here in the fourth quadrant. So we're looking at what two primary angles give me a sine of that angle gives me negative a half. And also this one here, which is way past, it's gone past 180, past 270 into the fourth quadrant. So here's how we do this, like what we've done on our last day. We always think, well, notice these are all kind of triangles that have been flipped around the axes. They're like kind of reflections across the axes. I always start with finding what would it be if it was in the first quadrant. So what would be that primary angle, or what would be that related acute angle here if it was in that first quadrant? And how we do that is forget about the signs, forget about negatives. So sine of what angle is a half? Oh, half is one of our special numbers. So if I think about that, that comes from our 2, cut it. This is 60. This is a 1. This is 30. And we're saying, well, this is root 3. So sine of what angle is a half? So sine of is opposite over hypotenuse. So sine of 30 is a half. So the first angle we get here is the related acute angle must be 30 degrees. So if it was in the third quadrant, that's 30 degrees, which means it's been flipped around, It's here and here. So now we have to just determine the primary angles. So notice if this terminal arm lies in the third quadrant, it's got to be 180 plus 30. So our angle that we need for our solution is 180 plus 30. It's our first angle, 210. So 210 degrees, and if you check on your calculator, type in sine of 210, you'll get negative half. And then our last angle here is in the fourth quadrant, and that primary angle is 30 degrees. That last one is, I'm going to take 360, and I'm going to subtract that 30, and I get 330. So these are our two angles that satisfy this problem up here. Just to recap, even though it says cosecant, you're going to rewrite it in terms of our three primary angles. I got it in terms of sine, and redo the problem like we would have done. I guess we would have done it today that way, because you're watching this tonight.